Okay, how you doing? We're going to talk about 45, 45, 90 special triangles. So one thing I definitely want to talk about is coming up with this little tool that I've got here, which is basically just a triangle with the 45, 45, 90 special triangles on it. So first things first, I'm just going to highlight a couple of things. Across from the 45 degree, what I want you to know is that whatever that angle is going to be equivalent to the same angle that's across from the other 45. Okay, so because their angle measures are the same, so are their length measures. Now, the next thing we need to talk about here is that across from the 90, you have this measure of whatever the leg is times root 2. So these are important. We're going to use these in a second just to show you how. So again, much like I did in my other video of 30, 60, 90s, what I use this tool to do is I just use it to set up my equivalent statements. So I come over here and I go, okay. Across from the 45 is what x is. So across from the 45, I set that equal to x. So 2 root 2 is equal to x. Across from this 45 is also what x is. And then L, I come up here and I say, okay, L is equivalent to this x root 2. So now what I do is I go ahead and I look at it and I go, okay, which one of these allows me to solve for x? And what I find is that, well, hey, lo and behold, x is already solved for is 2 root 2. So to calculate the value of L, I just simply come down here and I do a little substitution. So when I do some substitution, what I have here is that L is now equivalent to x, which is 2 root 2, and I'm going to multiply that by root 2. So this requires you to know a little bit about radical laws. So if I have a radical with the same index, so they're both root 2, then I can multiply their radicands, which is just the number that's underneath. And then what I have here is that I would simplify from there. Well, if I ever have identical roots multiplying each other, the answer is just the radicand. So root 2 times root 2 is just 2. So this becomes L is equal to 2 times 2. So in this case, L is equal to 4. And there you have it. I'm done problem number 1. So I move on to number 2 here. So number 2 says, okay, well, what happens if I've got this triangle here, and it's got the hypotenuse being 10, it's got this x here, and I need to know to figure out what the leg is. So again, I'm just going to use my red pen here. I'm going to set up my equivalent statements. So again, across from the 45 is x, so over here it's x, so I'm just going to write x equals x, which is not a big problem. But then I come up here and I see 10, well, I'm going to say 10 is equal to this x times root 2, so 10 equals x root 2, and then just for the heck of it, I'll fill out this other side over here, which is also x. So again, now what I do is I come up here and look at which one of these is going to allow me to solve for the x, and it just so happens to be 10 is the one that's going to let me do it, because I have only one unknown in the equation, which lets me solve. So I come down here and I write this out. So I say 10 equals x times root 2. So there's a couple ways you can do this. If you don't know about rationalizing the denominator, but you know a little bit about roots, what I'm going to do here is called clear the root, I like to call it, where if I want to get rid of this root 2, I just multiply it by another root 2. Now it will leave a 2 here, but it's a lot nicer than having that root 2. So I'm just going to multiply by root 2, multiply this side by root 2, and what we now have is that 10 root 2 is equal to, now don't forget this, root 2 and root 2 is 2, so I get 2x. Now it may seem a little bit preposterous to you that you're not doing something that gets rid of x and by itself right away, but what it does is save me a step doing of rationalizing the denominator. So what I can do is now solve for x, divide by 2, divide 10 by 2, and what you have here is that x equals 5 root 2. Which is nice, because I go up here, and the x that I was calculating for was the blue one. Okay, so this is my red x. I want you to be aware of that this is the red x. So this was, I was solving for the red one. Okay, so I found the red one to be this. And I come up here and I go, okay, well the blue x and the red x are equal, just for color's sake purposes. So therefore, this x is 5 root 2. So my final answer to this one is x equals 5 root 2. If I'm putting it on a test, box it up, and we're good to go on. So let's go on to example number 3. So again, example number 3, I like to use my little triangle here that I've created as a little tool. So in red again. So I come up here and I go, okay, across from the 45, we know that this is x. Across from the other 45, we know that that is x. And then we have 2 root 6. So instead of writing 2 root 6, I'm also going to say, okay, well that's equivalent to whatever x times root 2 would be. So x root 2. Okay, so now I've got this equation that helps me solve for x. While not pretty, I can still solve it if I want to. So here we go. So now I come down here and I write out my equation, which is 2 root 6 is equal to x root 2. So again, I like to use the idea of, if you want to rationalize the denominator, you can rationalize the denominator. It's however you want. So in this one, I'm going to use rationalizing the denominator as opposed to this one. So I'm going to go ahead and I'm going to go square divided by root 2, divide by root 2. So now I can get to directly before is that I've got x equals 2 root 6 divided by root 2. So all I have to do now is figure out how I can simplify it. So I could just go ahead and multiply by root 2 and then do that. But there's something else I want you to know. Much like the multiplication property where it allowed you to multiply what was underneath, if you have the same root, so they're both the square root, I can just divide what's underneath here. So that makes it a little bit quicker instead of having to go through all those steps and then simplify the radical. So what I'm going to do is I'm just going to take 6 divided by 2 and put it under the same root. So this ends up becoming 6 divided by 2 is 3. So root 6 divided by root 2 is root 3. And there I have that x is equal to 2 root 3. So again, I wanted to calculate x up here. So if I want to calculate the x, so this x up here, just so we know, is 2 root 3. So I hope you understand what we're doing here, and that's the final answer, 2 root 3. So I hope that helps with whatever you're doing.